Welcome to aminacademy.com and engineering thermodynamics. Let us discuss about terms relating steam formation. First one, sensible heat of water, that is HF. It is defined as the quantity of heat absorbed by 1 kg of water when it is heated from 0 degrees Celsius, that is from freezing point to boiling point. It is also called the total heat or enthalpy of water or liquid heat invariably. It is reckoned from 0 degrees Celsius where sensible heat is taken as 0. Now, for example, there is a sensible heat added to it for 0 to 0 degrees to 100 degree Celsius. Suppose water is heated, the total heat will be 4.18 into 100 minus 0, which is equal 418 kilojoule. That means heat added when 1 kg of water is heated from 0 to 100 degrees Celsius, heat added is 418 kilojoule. This is a sensible heat. Next one, further we will explain what is sensible heat. Look at this figure. Campfires emit radiant heat which is felt as sensible heat because it increases the temperature of your body. That means suppose you are standing near the campfire, you feel hot in your body. That means your body senses the surrounding heat. Sensible heat is literally the heat that can be felt. It is the energy moving from one system to another that changes the temperature rather than changing its phase. For example, it warms water rather than melting ice. In other words, it is the heat that can be felt standing near a fire or standing outside on a sunny day. Sensible heat is used in contrast of latent heat, the heat needed to change from one form of matter to another, which does not change the temperature, as the two are essentially opposite. For example, in a cooling system, condensation forms due to removal of latent heat, and the refrigerant cooling liquid changes temperature due to sensible heat. The sensible heat capacity then described the capacity required to lower the temperature, whereas latent heat capacity is the capacity to remove the moisture from the air. The temperature goes up, so that's sensible heat, but once it starts melting, that heat is latent heat and is represented by the flat parts of the line during the melting or evaporation. Yeah. Next one, latent heat or hidden heat. The latent heat is defined as the heat or energy that is absorbed or released during the phase change of a substance. It could either be from a gas or to a liquid or liquid to a solid and vice versa. Latent heat is related to a heat property called enthalpy. That is, the heat energy is used for phase changing of water. Is called latent heat or hidden heat. Next is for further explanation of latent heat. Look at here. Latent heat is the heat required for an object change phases, that is melt, boil, freeze, etc. This is energy closely related to enthalpy. In figure here, very cold ice has heat added to it. The temperature goes up so that the sensible heat, but once it starts melting, that heat is latent heat and is represented by the flat parts of the line during melting or evaporation. This area is melting or evaporation. The reverse thing is condensation. When temperature is increased, the phase changes happen. Adding heat to water can either raise the temperature or change the phase. The heat that changes the temperature is sensible heat. The heat that changes the phase is called latent heat. Fusion. Latent heat. The latent heat of fusion is the heat required for an object to go from the solid state to liquid state. That is called latent heat of fusion, or vice versa. Since its value is generally much higher than specific heat, it allows you to keep the beverage cold for much longer by adding ice than simply having a cold liquid to begin with. It's also why frozen meat takes a long time to thaw, but once it's thawed, it heats up quickly. The latent heat of fusion is also referred to as the enthalpy of fusion. Vaporization. Vaporization. The latent heat of vaporization is the thermal energy required for a liquid to vaporize to a gas, or the amount of heat is released when a gas condenses to liquid. The latent heat of vaporization is also referred to as the enthalpy of vaporization. Water has a high latent heat of vaporization, which is why steam burns are so dangerous. When steam burns a person's arms, for example, this energy transfer causes the steam to condense, which uses much more energy than simply changes the temperatures. Hot water could also burn. However, if a person were to get a hot water burn, that would only change the temperature of the person's hand and the water and will not cause the phase change. Therefore, steam water burns are much worse than hot water. Means if steam burns your skin, it gives more harm than hot water touches your body. Here, look at this figure. Solid to vapor, latent heat of sublimation. Vapor to liquid to solid. Vapor to liquid is called latent heat of vaporization. Liquid to solid, latent heat of fusion. The specific latent heat of a substance is the amount of energy needed to change the state of 1 kg of the substance without changing the temperature. The distinction from latent heat is due to the term specific, which tells us that substance is being measured per unit mass. In addition, since specific latent heat is measured per unit mass, it is an intensive property of matter. The specific latent heat represented by the symbol of a material is a measure of that heat energy. Specific latent heat can be found using the formula. Rearranging the formula, we get that the things required. It is the specific latent heat for a particular substance, either LF for the fusion or latent heat of vaporization, LV. It is the thermal energy released or absorbed during the phase change of the substance, usually kilojoule. It is the mass of substance, usually kg. This is the latent heat of vaporization and latent heat of fusion. Like next, dryness fraction. Dryness fraction is defined as the ratio of mass of dry steam to combined mass of dry steam and mass of liquid mixture. It is denoted by X. Dryness fraction X equal to mass of vapor, that is, and mass of the vapor, Me plus mass of liquid. That is the ratio of mass of the dry steam or sum of the dry steam plus combined mass of dry steam and mass of the liquid in mixture. Here, look at here. This figure, this is a wet steam. Here subcooled liquid, here superheated steam here. Dryness fraction, further explanation. Steam content containing 5% of moisture by mass also contains 95% of steam. The steam is described as having dryness fraction of 95% because it have 95% steam divided by 100% of mixing water and steam, so it's 95% dry. We can say 0.95 also. Likewise, steam containing 1% moisture has a dryness fraction is 0.99. The equation to calculate the steam's dryness fraction is mass of dry saturated steam over mass of dry saturated steam plus mass of water in the steam. This formula is important for steam calculations. Wet fraction is opposite that mass of water in the steam over mass of the water in the steam plus mass of dry saturated steam. Next is, that is we can write with x equal, in formula wise we can write mg over ms mg, ms plus mw or m. Now next is total heat or enthalpy of wet steam H. The actual enthalpy of evaporated wet steam is the product of the dryness fraction and the specific enthalpy H's. From the steam tables we can find those things. Wet steam has less usable heat energy than dry saturated steam. Here how to calculate enthalpy of enthalpy of wet steam is H wet equal HF plus X into HFG, kilojoule per kg. This is an important formula for calculating enthalpy of wet steam. The enthalpy of wet steam is the amount of energy that results when it is created from a liquid, typically at its boiling temperature in the transition from liquid to gas. There is wet steam and dry steam. Wet steam has an enthalpy that's related to the dryness fraction, the mass of water and the mass of steam. Therefore, total heat, enthalpy of that heat equal to HF plus X into HFG. Superheated steam. Superheated steam is a steam at a temperature higher than its boiling point for the pressure, which only occurs where all the water has evaporated or has been removed from the system. That means dryness fraction is 100% here. For superheated steam, the formula is like H super is equal HF plus HFG plus C into T super, temperature superheated, minus Ts. The advantage of superheated steam as follows. By superheated steam, its heat content and hence its capacity to do work is increased without having to increase the pressure. Superheated steam is done in a superheater which obtains its heat from waste furnace gases which could have otherwise passed uselessly up to the chimney. That means its performance will increase. That is for turbine. In that engine, turbine, steam engine and turbine, if you use the superheated steam, the performance will be more increased. High temperature of superheated steam results in an increase in thermal efficiency. Since the superheated steam is at a temperature above that correspond to its pressure, it can be considered considerably cooled during expansion in an engine before its temperature falls below that at which it will condense and thereby become wet. Next, we will explain about volume of wet and dry steam. How to calculate and solve the volume of wet and dry steam, that is enthalpy. The volume of wet and dry steam is illustrated by some examples. Look at here. Now, the formula for calculating volume of wet and dry steam is V equal to XUG plus 1 minus XUF, where V equal to volume of wet or dry steam, wet and dry steam, X equal to dryness fraction, Ug equal to specific volume of dry steam, UF equal to specific volume of water. And let's solve this problem. Given that the dryness fraction is 22, the specific volume of dry steam is 12 and the specific volume of water is 8. Find the volume of wet and dry steam. X equal to dryness fraction is 22. Ug equal to specific volume of dry steam is 12. UF equal to specific volume of water, that is 8. So formula is V equal to XUG plus 1 minus XUF, where V equal 22 into Ug is 12 plus 1 minus 22, 1 minus 22 into 8, that is V equal 22 into 12 into minus 21 into 8. So V equal to 264, that is 22 into 12 is 264, minus 21 into 8 is minus 168. So V equal to 96, proper unit of volume. Next, volume of superheated steam. Specific volume of the superheated steam. Its volume occupied by unit mass of superheated steam corresponds to given pressure of superheated steam generation. Superheated steam acts like a perfect gas. Therefore, the law of perfect gas is P1 V1 by T1 equal to P2 V2 T2 is acceptable in this calculation. Is applicable to superheated steam. Let Vg equal to specific volume of dry saturated steam corresponding to given pressure of steam generation is m cube meter cube per kg. Ts equal to absolute saturation temperature correspond to given pressure of steam generation. T super equal to absolute temperature of superheated steam. P equal to pressure of steam generation. Then V super, volume of superheated steam is the required specific volume of superheated steam. Then it above formula P1 equal to P2 because pressure is constant. While expansion pressure is constant, that V1 equal to Vg, V2 equal to V super, and T1 is Ts and T2 equal to T super. Then we are using the formula V1 by pressure is constant, so V1 by T1 equal to V2 by T2, that is Vg over Ts equal to V super by V. Then V1 equal to Vg, V2 equal to V super, then T1 equal to Ts, T2 equal to T super. Therefore, Vg by V super is equal to Vg into T super and Ts. This is a Vg. Vg. Therefore, V super is volume of specific volume of superheat is Vg plus T super by Ts, meter cube per kg. So far we discussed about some definitions and explanation of some of important terms relating to steam formation. We have done. Please subscribe our YouTube channel.